with the same charge repel.
Repel. What does it mean? Repel means push away from one another. Like if we have something charged with positive charge, like positive, it's like plus. Positive with positive. Are they attracted? No.
Is it like magnet?
Perfect. It's exactly like magnet. If we have positive and positive, are they attracted?
No.
No. But if we have positive and negative, they will attract?
Yes.
Yeah. If we have negative and negative, will they attract? No. So read it again. Particles with the same charge?
Particles with the same charge repel or push away from one other particle with opposite charge, attack one other or pull together.
That's right. So we can notice all of them. Positive was positive, repel. Negative was negative, the same thing, push away from one another. But the last one, positive was negative, will attract. Open the next page, please. 487. 487. You can fill in this table quickly. You will study this math in grade 7, but it's included here, so we have to fill it the page. Ahmed?
Yes.
Read this part, please. In the dryer?
In the dryer, atoms and clothing.
You know what are atoms, Ahmed?
Yes, I know.
Atoms is the smallest thing of the matter. They are tiny, tiny things.
Yes.
Atoms in clothing gain
Or lose electrons. Each piece of clothing becomes charged. The positively charged surfaces attract the negatively charged surfaces.
Right.
As a result, the clothes stick together.
As a result, the clothes stick together, like here. Look, this sock is negatively charged. This wall is positively charged, so they are attracted to each other. And if you have a balloon and wrap it with your hair, then if you put it to the wall, it will stick. Thanks, Ahmed.
You're welcome.
Saad? Saad, can you hear me?
Yes.
Saad, electric charge?
Electric charge can build up on objects.
This build up
Is static electricity.
Static electricity. What static electricity mean?
Static electricity, not moving objects. The
Objects with opposite electric charge.
The electric charged attract each other. Objects with the same charge repel each other. When you brush your hair, electrons move from
each strand of hair
to the brush soon.
Okay. All the strands are positively charged. All the strands having the same charge causes them to repel one another and stick out. A charged object can attract a neutral object like this. You can see if you wrap a balloon on your hair, the balloon picks up extra electrons that gives it negative charge. When you bring the balloon near a wall, electrons and a small part of the wall are repelled and move away. leaving a positive charge at the wall surface. As a result, the balloon sticks to the wall. And this is the reason.
غني بالأ
This episode was made possible by generous supporters on Patreon. Hey crazies, there's a question I get every once in a while that I think we're ready to answer. What the heck is electric charge? Let's just jump into it. I don't even think we'll need quantum mechanics for this. Just like objects can have mass or temperature or speed, objects can also have charge. It's just a property. Things like balloons, hair, or pieces of plastic become charged by transferring electrons. Super zoom. Inside atoms, protons and neutrons are the heavier particles in the center. Electrons are the lighter, looser particles on the outside. So they're what can get gained or lost when things rub against each other. If we rub a balloon against someone's hair, the balloon and the hair become attracted to each other. Now that they're charged, they don't even need to touch to affect each other. This is just like how masses attract in Newtonian gravity. We even said in the previous video there were a lot of similarities. So this shouldn't be a surprise if you're already subscribed. Subscribe. Unlike mass though, charge has two different types or flavors. We call these two types positive and negative, but only for mathematical convenience. They're just labels. We could have just as easily called them up and down or good and evil or dingleberry and snozberry. The snozberries taste like snozberries. The two types show opposite behaviors, so as long as the labels are opposites, we're fine. It doesn't even matter which ones we label which. The labels we use today were decided 270 years ago in 1748 by Ben Franklin. It might have been better to label them the other way, but now we're stuck with it. Thanks, Ben Franklin. Hop on my filthy back. Anyway, where was I? Oh, right. Opposite behaviors. Opposite charges attract, and like charges repel, which I think is pretty common knowledge at this point. That's what makes atoms the way they are. The protons are positive, and the electrons are negative, so they're attracted to each other. Unfortunately, since electrons are the things that move around and electrons are negative, we kind of have to think backwards. An electron gain makes an object negative, and an electron loss makes an object positive. The balloon from earlier gained electrons from the hair, so it became negative and the hair became positive. But that doesn't really explain what charge is. As Cameron McHenry pointed out, sure, objects become charged because their parts are charged. But electrons are elementary particles. They don't have parts, and neither do any of these other charged particles. So what the heck is charge? To answer that, we need to talk about the EM field. Charge and the electromagnetic field are inextricably connected. You can't really understand one without understanding the other. What's a field again? Okay, that's a fair question. A field is a value or set of values assigned to every point in space. But jumping right into the EM field could be a bit overwhelming. Let's start with gravity. It's a little easier to imagine and a lot easier to work with.